All right, we are at section 1.4, and we're going to look at systems, but we're going to look at nonlinear systems. So far we've been looking at lines that intersect each other. We want to go on to what happens if they're not lines, what happens if they're curves. All right, let's go for it here. So what a nonlinear system looks like, there it is. There's only 2 examples here in the textbook because it works all the same way here. So, and then there's an application section here. So let's go for it. So what we do is we take the non-linear equation. Notice though, actually, more so it's the fact that the y value is linear, and if the y value is linear, it really doesn't matter which way you go. Okay, that's one case. In the other case where it's going to be nonlinear here. So if you see y by itself or y to the 1 power, it doesn't matter which way you go. You pick one or the other, but we are going to do it the substitution method because it's the best way to do it here. With these guys here, we're going to solve them for y. Solve one of them for y. Doesn't matter which one. I'm going to move the x squared over, so it becomes a negative x squared plus 2. And what we're going to do here, we're going to plug it in or substitute it back into the other equation. So now we go 2x plus, and now we have the substitution of negative x squared plus 2 is equal to 3. There it is. And from here on out, we start solving. That's what it's about. So let's go for it here. Let's move it out of the parenthesis. In fact, the x squared is going to first. Then we got the 2x, and then we have the 2 all the way over here. And once I see this whole setup of x squared and then x, you should realize that you are going to factor here in a little bit here. So let's move the 3 over so we can set equal to 0 to start factoring, the factoring process. Okay, in this case, I don't like the negative in front of x squared, so how about just multiply through everything by x squared, or you can just change the signs everywhere. The 0 still remains 0, and now we have to solve this. So I need 2 numbers multiply to positive 1, add to negative 2. In this case, they are both the same. There's negative 1, negative 1. So x is equal to positive 1. Notice I just get one single answer. If I had 2 different answers, then I have to plug in both of them. We'll see that on the next practice problem. Okay, once I know that x is equal to 1, I'm going to back substitute that in. And it doesn't matter, first or second equation, it doesn't matter. I'm going to choose the second equation because then I don't have to deal with the squares of anything here. So plugging in the 1 in for the x value, 1 times 2 plus y equals 3, and 1 times 2 is 2. As we subtract the 2 out from both sides, we get the fact that y is equal to 1 as well. So there it is. There's our answer. Our answer is x comma y. And we have solved it. So again, if the y value is a linear value, we want to solve for y being the linear value. And then what we do is we work the rest of the way. The other type of problem is when the y value or the x value, they are not linear. Notice you have x squared, y squared in the first equation. You have the same thing, x squared, y squared in the second equation. All right, in this case, what you want to do is you really just want to eliminate one of the variables by the elimination method. Okay, so if y is linear or if x is linear, if you do see a linear value, you do by substitution, solving for the linear value. If none of them is linear, let's go with the elimination method. I got the top equation here, I got the bottom equation here as well, and I think I'm going to multiply the top or no, the bottom by 2. That'll make a negative 2y squared, and no change for the top. And there it is, no changes there, but I do have doubling of everything on the bottom. And notice what I got is I got the y squareds to be exact opposites of each other. In this case, when you add them up, the y squareds are gone as planned. All right, that's going to be, looks like 48. So when you divide by 3, that gets you a 16. Now careful here, remember whenever we take the square root of both sides of an equation, we have to put the little plus minus right here. So really what we have on our hands, we have two different answers. We have a positive 4 and a negative 4 in our hands. So in this case, we're plugging in two different values here. All right. So it doesn't matter which one or the other. You're going to plug into one of them. I'm going to just choose the bottom equation here. So now let me plug in the positive 4 first. Let's see what I get for my answer. Plug it in the positive 4. I get 16 here. And then when I do that, I'm going to move this 16 over. That makes a negative 9 now on that side. And then since it's a negative y squared, I can drop both signs. And I have two answers from here as well. So in this case, I have myself a positive and negative 3. So a positive value of 4 gets me a positive or negative 3y values. Okay, I'll keep that off to the side here. Let's go the other side. I'm going to plug in a negative 4. And you know, when you are squaring something, you know the negatives actually is just going to go out. So negative 4 times negative 4 is 16. And then we subtract 16 gets you a negative 9 and drop the minus or the negative signs and we get an answer of plus or minus 3 as well. So here it is. We've got a whole bunch of answers here. From the positive 4, we have an answer of positive 3 and negative 3. So positive 4 input gave us two different answers. Then we plugged in a negative 4. They give us a positive 3 and a negative 3 as well. So in this case, there are 4 different answers here for that problem here. All right, on to the application problem here. As we put it here. So Danielle bought 240 shares of stock at $40 a share. She also, on top of that, she also paid a broker fee of $100. She kept these shares for 3 years, during which time she received a number of additional shares of stock and dividends. So at the end of the 3 years, her dividends were worth $2,400, and she sold all of her stock. She did good here, made a profit of $7,100, of course, after paying the broker commission fee. All right, so how many shares of stock did she receive as dividends, and what was the selling price of each share of stock? Let's go for it here. So we're going to let X be the number of shares she received as dividends, P being the selling price. So grand total, if you think of, if you're multiplying these guys together, because her dividends were worth $2,400 at the end, we have X times P is equal to 2,400. Now the number of shares she sold at P dollars were the 240 shares of stock that she had originally, plus the dividends. All right, so if we set this up here, we got revenue that she received was 240 plus X times P. The cost would be 9,700. All right, and the profits that were made is right there. All right. Just looking at, trying to make sure that we understand where the $9,700 came from, and the $9,700 came from, she bought 240 shares of stock at $40 a piece. Let me just check that on a calculator just to make sure here. All right. That is correct. So this one right here is 240 shares of stock at $40 a piece. All right, and then again, profit would be $7,100. As you start solving for things, you notice that you solve for this and you get this as the answer. So we're going to set up a system of equations here. This one right here was her dividends worth it, and then her stocks worth right here. All right, so substituting that in, or we know that XP is equal to 2400. We're going to substitute the first equation into the second equation to make a third equation. From here on out, divide by 240, and we get P is equal to 60. So what is P? P was the price per share. We're going to back substitute it. Again, doesn't matter which one, top or bottom. Well, now we know that P is equal to 60. We substitute the 60 back in. Divide 2400 by 60 and get you 40. So here it is. Daniel received 40 shares as dividends and sold her stock at $60 per share at the end of it all. All right, let's try the practice problem together. So rework previous problem. Assuming Danielle's dividends were $1,950 after 3 years and her profits was $78.50. So let's set this up here. So first things first, the dividend price. The dividends were worth $19.50. So then let's look at revenue. Revenue was, okay, so she has 240 shares of stock plus the number of shares she received as dividends, right? And then all that at a P value of the price. That's the revenue she's going to sell it at. Cost. Here's the cost function. That was not really described that well in the previous example problem here. So she bought stock at $240, 240 pieces of stock at $40 a share, plus all she paid a broker fee of $100. That's where the $9,700 come from. All right, and what do we know? We know that revenue minus cost would finally be your profit. So careful here, big P and little p are different here. Little p is the price per share, the big P is the profit. All right, so plug this in here, revenue, what she got, plus the extra dividends she got at a certain price, cost and profit at the end of the day, $7,850. All right, move the $9,700 over. Distribute the P value to the 240 as well as the X. And I think we have our two equations that we need to set up. First equation is the dividend price she received. Second equation is technically the profits that she received all the way around. And we're going to solve it by noticing, hey, there's an XP multiplication. In the first equation, there's an XP multiplication in the second. So let's substitute. Let's substitute this little XP into the XP that's in the second equation here. All right, plugging it in here gets us 1950. Now we subtract 1950 from both sides. Divided by 240. Remember, this is the price. This is the price that she sold the shares at. So $65. She bought them originally at $40 a share. She's now selling them at $65 a share. All right, and let's plug it in. Let's plug it in and find out how many shares did she receive as dividends only. So I'm going to plug into the top equation here. So X times P equals 1950. Now it's 65 times X is equal to 1950. Divide by 65. and we get ourselves 30. Sorry, that was a quick one. Let me go back real quickly here. There it is. So X equals 30. And again, this is the number of shares she received as dividends. All right, so let's go for it here. Putting it all together here, Danielle received 30 shares as dividends, and then she sold her stock at $65 per share to make that kind of a profit. All right, hopefully that is a good introduction to these nonlinear systems.